The binding energy of deuteron 1H2 is 1.112 mega electron volt per nucleon, and an alpha particle 2He4 has a binding energy of 7.047 mega electron volt per nucleon. Then in the fusion reaction, 1H2 plus 1H2 giving you helium nucleus plus energy release Q is. So we have to calculate the energy release Q. So the reaction is deuterium, which is isotope of hydrogen, 1H2 giving you helium 2He4 plus some energy is released. So mass of deuterium is isotope of hydrogen. Deuterium is, that is 1H2. Mass of one deuterium is, in terms of atomic mass units, 2.01478 atomic mass unit. So there are two here. This energy must be conserved on this side. So the total energy of the reactant should be conserved in terms of, in the side of the total energy of the products. So when the product is formed is due to the phenomenon of nuclear fusion. So this is fused into helium nucleus. Hydrogen 2 deuterium fused into helium nucleus, and some energy will be released. That is the principle of nuclear fusion. Now there are two deuterium atoms. So mass of 2 deuterium that is equal to 2 into 2.01478, that will come around 4. If you double this up, you will get 2956. Yes, 2956 atomic mass units. Then similarly, mass in terms of mass of helium in terms of atomic mass units. So that we will calculate. Mass of helium, that will be around 4.00388 atomic mass units. Now energy of the reactant side, that is energy of 2 deuterium is, see, this is a mass in terms of atomic mass units for deuterium, that is 4.02956 atomic mass unit into 931. The energy released will be 4 into 931. Okay, they have given the binding energy here. So the total mass into binding energy is they have given already. So that is binding energy of one deuteron is 1.12. So that is, we have to multiply with this 1.112 mega electron volt. That is what they have given. So energy of the two deuterium is this much. So that you are going to get it as 4.48 mega electron volt. Similarly, energy of helium is 4.00388 atomic mass unit into given data per nucleon. This is number of nucleons mass into per nucleon, no, mega electron volt per nucleon into number of nucleons. Similarly, that is given as 7.047. So that will come around 28.21 mega electron volt, calculating. Now Q is energy of reactants minus energy of product or minus energy of reactant. So energy must be conserved. Whatever the energy it has on the reactant side should be the same energy possessed on the product side. However, this will have this much energy and part of the other energy will be released or to be absorbed. So that will be 28.21 minus 4.48, totally will get 24, nearly 24 mega electron volt. To be specific, it is 23.73 mega electron volt you are going to get. So the answer closest to that is option C, 23.8. So option C is the right answer.